Okay, so now I told you to trust me with some rules, but I kind of want to try to prove to you kind of intuitively why a negative times a negative does actually equal a positive. I want you to remember that when there's rules in math, we have to apply those rules to every new situation. We can't just break them because it's a little bit hard to understand at first. So I'm going to try a couple different ways to prove this to you. So first, I'm just going to do what you know about multiplication, and that multiplication is repeated addition. So I'm going to use the example of 2 times 3, okay? We can think of 2 times 3 being repeated addition of 2 or repeated addition of 3. So we could think of it as being 2 plus, I'm sorry, I want to do the other one first so I don't confuse myself later. Okay, being 3 plus 3. 3 added twice. Or you can think of it as being 2 added 3 times, okay? Either way, if we do 2 plus 3, or if we do 2 plus 2 plus 2, 3 plus 3, or 2 plus 2 plus 2, what's the answer going to be both times? Hope you got 6, okay? So we know that however we think about this repeated addition, the answer is a positive number. We had 2 positive numbers to start with. Okay, what if I take the opposite of the second number, and I say 2 times negative 3? I think this also kind of makes sense to you already. But now I'm going to do the repeated addition of negative 3. So negative 3 plus negative 3 then is negative 6. Or I could do the repeated not addition because negative 3 is opposite of 3. So I need to do the opposite of what I did here. The repeated subtraction of 2. Well, minus 2 minus 2 minus 2 is also negative 6. So I have proved to you a couple things, I think. I have proved to you that a positive times a positive equals a positive, and a positive times a negative equals a negative. Okay, so now we have our third situation where I'm taking the opposite of both of them. I got a negative 2 times a negative 3. Okay? So now I need to take the opposite of both of these situations, right? And instead of doing the repeated addition of negative 3 twice, I have a negative 2 now, not a positive 2. So I have to do the repeated subtraction of those, okay? So minus minus 3 minus minus 3. What? What are we talking about here? Okay, so let's just look at this first before I go on. Minus minus 3 minus minus 3. You know from our lessons about adding and subtracting integers that minusing a negative is really addition, right? So applying that rule here, this is really plus 3 plus 3, okay? So 3 plus 3, that's pretty easy. I know the answer to that is going to be 6. Okay, or we could think of it from this perspective, right? So since I did the repeated subtraction of, or since I did the repeated addition here of 2, now I need to do the subtract of 2 as well, because we've now changed that sign in this case. So it's minus minus 2 minus minus 2 minus minus 2, which is really, as we know, plus 2 plus 2 plus 2. Either way, that gives me a plus 6. So I'm trying to see if this will intuitively make sense to you that a negative times a negative must be a positive, okay? Or you can think of it this way, okay? How can 2 times negative 3 be a negative, and negative 2 times negative 3 is also a negative? These two examples can't have the same answer. They're different, right? They're fundamentally different. We took the opposite of this number. It's not a positive anymore, it's a negative. So we have to kind of reverse our thinking about it. Okay, I hope that kind of makes sense. All right, there is another way to think of it that requires a little bit of deeper understanding. So you can stop listening to me right now and pause this, or turn this video off if you want. Or if you think you know something about the distributive property, I'm going to try to prove it to you using the distributive property. Okay? So you can continue listening if you want a challenge, all right? So I got 5 times, actually I'm gonna skip the positive times the negative because I think you understand that. I'll just do negative 2, okay, times negative 6. Okay, negative 2 times negative 6. All right, so I'm going to, using what I know about the distributive property, I'm going to kind of prove why this must be positive. So I'm going to pull that -2 out here. I'm going to say -2 plus the quantity 6 plus -6. Okay? Now, using what I know about the distributive property, I can rewrite this as -2 times 6 plus -2 times -6. Okay? So, what do I know? What do I know about 6 plus -6? What does that equal? 0, right? So this quantity, maybe let me use a different color. This quantity in here has to be 0. Okay? So what is -2 times 0 then? Must it be? What must it be? It must be 0. So our quantity here has to equal 0. Okay? So even though I wrote it out using the distributive property where I distribute -2 to both the inside, I know that my solution must be 0 as well. Okay. All right, so this one's a pretty straightforward one. -2 times 6, we get that. That's intuitively true. We know that's going to be -12. Okay? So -12. So what must this quantity be for the answer to be 0? -12 plus what equals 0? Okay? I hope you notice that this has to be 12. It has to be a positive 12. Okay? So that means that -2 times -6 has to be 12. So I've proved to you, I hope, that a negative times a negative must be a positive. Okay? So I can't go about changing the rules of math for different circumstances. I must use all the rules of math that have been established. So using the distributive property, I can see why multiplying a negative times a negative is a positive. All right, thank you. Bye.